All right, so we've talked about work and we've talked about power. Next topic are machines. What are machines and how do they work? Let's see. What is our definition for a machine? It's a device that changes a force. Pretty simple, huh? Okay, so any device that changes a force is technically a machine. So what do machines do? They make work easier to do. Otherwise, we wouldn't use them, all right? So how do they make work easier? That's the trick. How can you make work easier to do? Well, you can change the size of the force that you need. You could either decrease the amount of force needed or increase the amount of force needed. You might want to think, why would I want to increase the force that I need? There's a trade-off in distance. Because I can also change the direction of the force. So if it's easier to push down instead of pull up, that might make the work easier to do. Or I can change that distance, which I referenced a moment ago, over which the force acts. So I can change the amount of force needed, the direction of the force that's applied, or the distance over which the force acts. Any of those three things may make work easier to do. Okay? So, how do we calculate this? Well, we need to look at the amount of work going in and the amount of work coming out. The amount of work going in is called the work input. Fancy name for work in. Input. I'm putting the work into the machine. It's the amount of energy you put into it. Right? And same formula for work. Work equals force times distance. So we still have force times distance, but specifically it's the force we put into the machine or that we apply to the machine. And the distance is the distance over which we exert that force on the machine. So we're specifically talking about the work done on the machine. Now, the work output is the work done by the machine. It's the work that comes out. So notice it's the work put out from the machine. It's the amount of energy you get out of that machine, right? Same formula, work equals force times distance. It's just a specific type of work. So it's the force coming out of the machine on whatever the job is, and it's the distance that force is exerted on the job or through the job. So I apply some sort of force over a distance into the machine, and the machine is going to do the job for me. It's going to exert a different force over a different distance. So my work in and my work out. So because of that nasty force called friction, that force that opposes the motion of an object, the work done by a machine is always less than the work done on the machine. So the work that I put in is always greater than the work that I get out. Why? Because some energy is always lost as heat. As parts of the machine rub together, that causes friction, okay? And some of the energy that I put in has to go to overcome that force of friction. Therefore, no machine is ever going to be 100% efficient. That's going to come later. We'll talk about efficiency. But when I talk about machines, machines have parts. Those parts rub against each other. That friction causes loss of energy in the form of heat, sound, light, other things. So the work out is always less than the work in. Okay, make sure you got all these words written down in your box. You record something that you heard me say that's not written on here. And make sure it's a sentence, not just a word, as well as a question that you're curious about. Flip it over, do your reading on machines, and I'll see it in class.